This scene depicts the aftermath of the 1908 Tunguska event, a massive explosion in Siberia caused by a cosmic impactor. While not caused by the Earth stopping its rotation, its destructive force is often referenced in analogies about rapid planetary catastrophes. While no real event documents the Earth stopping its rotation for 5 seconds, the Tunguska explosion exemplifies the catastrophic scale of sudden planetary disruptions that might be analogized to forces involved in a sudden halt scenario. The Tunguska explosion took place near the Tunguska River in the remote region of Siberia, Russia. This area is vast and mostly unpopulated, surrounded by dense forest and wilderness. Because of its geographic isolation, the explosion caused very few human casualties, but it generated a unique opportunity for scientists to study the effects of cosmic impact events in an environment largely untouched by human development. The Tunguska event unleashed an immense amount of energy, estimated to be between 5 and 30 megatons of TNT. This explosion occurred high above the ground, at an altitude ranging from 5 to 10 kilometers. The resulting shockwave was so powerful that it flattened approximately 2,150 square kilometers of forest, knocking down millions of trees and leaving a vast area of destruction in its wake. Although the Earth has never actually stopped spinning suddenly, many scientific models and studies have explored the theoretical environmental and geological consequences if such an unprecedented event were to happen for just 5 seconds. These studies provide insight into the devastating potential impacts on the planet's stability and ecosystems during a momentary halt in rotation. Photographs documenting the widespread earthquake damage from events like the 2011 Tohoku earthquake and tsunami in Japan provide powerful visual evidence. These images help us grasp the immense scale of destruction that might be expected from the extreme inertial forces unleashed if the Earth were to suddenly stop rotating, causing catastrophic shaking and structural failures worldwide. The Earth completes one full rotation every 24 hours, meaning that at the equator it spins at a staggering speed of about 1670 kilometers per hour. An instantaneous stop of this rotation would unleash inertial forces far beyond anything experienced in regular earthquakes, thousands of times stronger, capable of causing massive geological upheaval including landslides, fault ruptures, and widespread devastation. During actual geological disasters, emergency response is critical. It involves carefully coordinated search and rescue missions, the evacuation of affected populations to safer areas, and the organized distribution of aid and resources. Long-term recovery efforts include rebuilding infrastructure and planning to mitigate future risks, a process essential to manage the aftermath of any global catastrophe triggered by sudden planetary changes. Images following Hurricane Katrina in 2005 reveal the devastating consequences of natural disasters involving the displacement of large volumes of water. These photos vividly show the widespread destruction of homes and infrastructure, as well as the significant human suffering caused by flooding. This situation mirrors what might occur after a sudden stop in Earth's rotation, where massive flooding and water surges could cause similar or worse impacts around the globe. The 2011 Tohoku earthquake was one of the costliest disasters in history, resulting in over 15,000 fatalities and causing economic losses estimated at more than $235 billion. If geological catastrophes were triggered by sudden, drastic planetary changes, the scale of casualties and damage could increase exponentially, reaching numbers far beyond those in known historical disasters. When large-scale natural disasters strike, they are often followed by increased scientific understanding and important regulatory reforms. These changes aim to reduce the likelihood of similar events causing as much damage in the future by improving monitoring systems, updating building codes, and enhancing emergency preparedness, all of which help build resilience to protect communities worldwide. Memorials dedicated to the victims of major natural disasters play a vital role in society as places for collective remembrance, reflection, and mourning. They remind us of humanity's vulnerability in the face of catastrophic events and the importance of ongoing preparedness, resilience, and scientific research to prevent or lessen the impact of such tragedies in the future.